Okay, so we've already seen how to pin stuff in space, and we've seen how you can take any kind of animated geometry and follow the animation for a couple of points and simulate all the rest. But there's another case that you might want to cover, and that is when you have a static object that is moving and you want to attach cloth to it. So for example, a waving flag. So what I have prepared here is the flagpole with a little sphere on the top to make it look nicer. This is something you should totally be able to do. And then I have my flag here prepared in form of a planar patch with a little bit higher resolution than default, and then I gave it a color. And then as we will see later on, I've prepared also very simple animation here of my flagpole, so it moves then around and we will see how the flag is attached to that. Now, first let's do the basics. So we create a cloth constraint, of course, and my flag here will be the active part of the simulation, and the flag, since we animated it, will be the collision object and something we want to attach it to, and this is why it goes into the static object. Let's put this whole thing into the Vellum solver, of course, and see what happens. And what should happen is that the flag just falls down because there's nothing connected. By the way, let's turn off the animation for now. And yeah, so at least it works, but you know, it's not connected. Now the connection we are looking for is called attach to geometry. And if you actually look for this in the menu, you will find it Vellum attach to geometry. And of course you could create this from scratch by just setting the constraint type to attach to geometry. And the interesting thing is it actually right away works because it will automatically understand that there is a static object and an active object, and it will automatically connect them. The problem now is when you run this, it looks a bit odd, because now it almost looks like the flag is either made of metal or that we have a really weird wind that is very strangely static. So what's going on here is something you have to be really careful with, because the Vellum attach to geometry constraint by default simply connects every single point of my active object to the closest point of any static object it finds. That, by the way, also includes if you have multiple poles, you could actually merge them together, and then you will get two poles on each end, which will be automatically connected, which is interesting, but it just shows you again that it always looks for the closest connection it can find. And here you can see now the points always choose the closest pole they can find. We will not do this here, but this is something maybe we can then play around with for another example. But how do we solve this? Because this is not how you attach a flag to a pole. You only attach, the edge of the flag. There's actually a parameter called max distance that we can use to define, okay, how far away should each point look for a connection? And when you choose the right number like this, you can actually get relatively quickly a result. What you can see here is that this is based on the points of the active geometry. If I would increase the resolution of my flag here by changing the edge length in the planar patch, I would also get more connections. But it then just looks for the closest location on the surface of the geometry, of the static geometry, because here you can see there are no points or anything that it could connect to, and this is because this button here, or this checkbox here, is turned on, use closest location on primitive. So it's not that only points can be connected, the points from the active object will always look for the closest location on the surface of your static object. Now if you look at the result now, it looks much better, because now only the edge is connected, and if you run this, the flag can freely fall down. It's just that we have to change a couple of settings because it's a bit too stretchy. That's of course partly because we have a lot of geometry. So let's make the stretch stiffness a bit higher. And maybe the bend stiffness we dial down so that we get more folds. And also while we're at it, let's add a little bit of wind. Now, under forces, we have a wind, but I prefer to do this inside of the Vellum solver because there, so let's turn this off, because there I can also add my pop force if I want. And of course, this has to go into the force node. And here I can say, okay, the direction is positive x for me. So let's increase the force direction and the amplitude of my noise. And then we should get some nice result. Let's make it a bit stronger, maybe 3. Okay, maybe 8. And with this, I also increase the amplitude of my noise, which I will make a little bit smaller. and a bit stronger, you know, just play around with something that works for you. That's not too bad. It's still way too stretchy, even though I increased the stretch resistance. And the reason is simply that we might need a little bit more of substeps here. I go the cheap route though. I will just lower my resolution for now so that it's faster for this example. If you wanted to have this kind of detail, of course, you would just have to increase the substeps, and that would be totally fine as well. And the result would probably look pretty good. So as you can see now here, we have a waving flag that is connected to our static object. That's not too special though, because currently our static object is not moving, so we could have done this by just pinning the flag in space as well, but it becomes obvious where the difference is when we start to animate the flag. And my tip here is I made sure that my first frame, is in a neutral position so that I can first connect my flag and then run the simulation, and only then the movement begins. This is something I would generally recommend, to have kind of a neutral start position to first connect everything. Otherwise it becomes a lot more tricky to set this up properly. And now the result looks like this with the actually moving pole, and we can now see that it really follows the static object and the result is accordingly correct. Now, one small thing, this was relatively easy with the max distance because it just takes all the points close to the pole and attaches them. But this is not always possible, and in this particular case, there is a reason why I would not work like this, because simply this is not how a flag is actually attached to a pole. If you look at it in reality, only a few positions in the flag are actually connected. I mean, yes, sometimes it's connected to a rope, but sometimes it's also connected just on a few elements. So what we can do here instead is we don't use the max distance, but we can use the geometry groups. We have here a group for the active flag, and theoretically we could also use groups on the collision geometry, but we don't need to do this for this example. But we can choose groups here of the actual flag. So let's create a group that only covers a couple of those points. One way of doing this is, of course, with a group, and then I would say set this to points, and let's call this attach group or something. And then I use a bounding region, and I really just position a box here at one particular point, maybe something like this. And let's set this to bounding object so it actually takes the second input. And then I would use a copy and transform that we've seen in one of the very first videos to just copy this box by a certain distance. And we can do this, for example, here with a translate, and maybe this kind of distance. And then I can create multiple copies of that. And if I play around a little bit, I can find something that works for me, maybe something like this. And you can see now that it only catches a couple of points. I wasn't really careful here. You can do a better job than me, because this one, for example, didn't get any. But that doesn't matter for this example. Okay, maybe fix it a little bit, maybe like this. Did this help? No. So anyway, now I have a few connections. That's all I care about. And I can use this group here in my group of the geometry, not the target geometry. That would be relative to the static object. But here I can now choose from point groups, the attach group. And you can see now only those are now connected. And this will probably look a bit nicer when you simulate this. So let's run this again. And the difference now is that you have these kind of, okay, it's a bit too fast, the animation, but maybe on this frame you can see it. So there are certain areas that can still move freely and others that are connected. Let's actually increase the substeps a little bit, because then the result will be better. Even with a low resolution, it looks kind of wonky. So let's increase the precision a little bit. Yeah, that's nicer, I think. So still, you can see like here that only a few points are actually connected. And if I would increase the resolution again, we would get an even better result, I think. So let's change our stiffness a little bit, actually, maybe something like this. And then it would look, I think, relatively okay. So with a couple of adjustments, it looks like this. A bit less wind, but you can see it works, and it even collides with the pole, which is the whole idea. So yeah, this is how you attach cloth or any kind of soft body to a static object, which is especially helpful when this is moving. And for this, you use the attach to geometry constraint. So I hope this is helpful. Thanks very much, and see you later. Cheers.